Good morning, it's Jeremy. It's August the 4th. In the last few videos, I've looked at receiving various HF signals, and I thought I would look at SW Radiogram, which I looked at about 4 years ago, and I thought it would be interesting to see what they were up to. I get an email every week with the program details. So on Saturday at 7 p.m., which is 2300 UTC, I received a transmission on 9455 kilohertz. I'm just looking at the blog post here. Here's the setup. I'm using my loop antenna because, as I mentioned in previous posts, I'm right next to a power line, and the loop antenna is directional. It also has some noise rejection capability. So what I did is I tuned it to 9455 kilohertz. I'm using the SDR-IQ receiver, which is my go-to HF receiver. It's a 14-bit ADC, so it gives me a good reception. I'm using SpectraView software, and what I'm doing is I recorded both the audio and the video of SpectraView using Camtasia. As well, I use the record feature on SpectraView. So basically, I got two audio files that I could use. I put the audio files into Audacity, and I used VB cable to feed Audacity to the FLDigi MFSK32 and 64 decoder. Here's the transmission schedule. So it was Saturday at 2300. That's the broadcast I was listening to. The transmitter is in Okeechobee, Florida, WRMI. And I did a quick propagation study from my location in Toronto down to Okeechobee in Florida. And at 30 meters at 2300 hours, the propagation was 80%. Now I just used... For the transmitter, I used 10 kilowatts at 60 meters dipole, which is probably very conservative in the sense that I'm sure it's a lot more power, maybe 50 to 100 kilowatts with a directional curtain array of some sort. I'm not too sure what the antenna is, but anyways, my selection was very conservative. And on the receive end, I've got a dipole of 20 meters. So 80% it's quite conservative. So we should have fairly good transmission according to VOA cap. And here's a screen capture of SpectraView. We'll see that in a minute. And there is the decode of the audio using MFSK32. You can see the bandwidth goes from around 1750 to, from 1250 to 1750 kilohertz for MFSK32. There's a bunch of pictures that were sent, and they're sent at MFSK64. And the bandwidth here is from, let's say, about 1,000 to 2,000 hertz. So let's go to, let's just see what the original transmission sounded like. I've got a screen capture there. So you can see the noise is around minus 125, and the carrier is pumping between, let's say, minus 90 and minus 150 dB.
Shortwave Radiogram, presented by Kim and Ruel.
You can also see I'm recording the audio down here, so I've got a WAV file coming out of SpectraView.
Welcome to program 411 of Shortwave Radiogram. I'm Kim Andrew Elliott in Arlington, Virginia, USA. On Shortwave Radiogram, we transmit digital text and images on an analog shortwave broadcast transmitter. To learn more information about our project, visit swradiogram.net. That's swradiogram.net. On today's program, content in MFSK32 and MFSK64, the world's smallest snake makes a comeback in the Caribbean. India and the United States launch a satellite to track the Earth's surface, and our images of the week. First program preview in MFSK32, that's MFSK32.
Okay, so now we switched on the MFSK32. So let's go over to FLDigi. There's FLDigi. Let me clear the screen here. And I've got my audio file set up here in Audacity. So let's just play that. And we're decoding at MFSK32. You can see the spectrum appear down here. Let's say from 1250 to 1750, and it'll start to decoding. So now it's decoding in MFSK32. Later on in the file, what happens is the pictures are sent at MFSK64. So in the blog posts, I've got all the pictures that were sent. So anyways, that's SW radiogram, very effective use of MFSK. Of all the HF modes I've studied, that's the one that impressed me the most because it works at a negative signal to noise ratio, and you don't need any UTC time to 1 second or anything like that. It's a pretty robust mode.